Hello viewers, welcome once more to this series on laboratory measurement in public health engineering. The raw water generally has some amount of bacteria present in it. During the process of water treatment, of sedimentation and filtration, some of it gets removed. The remaining is destroyed during the process called disinfection. Disinfection is generally achieved by adding chlorine in suitable form and suitable dose. That is why this is popularly also known as chlorination. Chlorination is also done in order to arrest any possible growth of bacteria in the water distribution system. When we add chlorine to the water, a part of it is consumed in destroying the bacteria and some part is available at the consumer end. It is recommended that an amount of 0.1 to 0.2 ppm of residual chlorine should be available at the consumer end to achieve the desired purpose. In this program, we shall see as how do we measure residual chlorine in water. Generally, the measurement can be done by three techniques: iodometric method, spectrophotometric method and using a residual chlorine kit. In this program, we shall see as how do we measure using iodometric method and residual chlorine kit. First, we will see measurement by iodometric method. In this method, we need simple glassware like a burette with the burette stand, a glass funnel, conical flask of 250 ml capacity, beaker, pipettes of 10 ml, 5 ml and 1 ml capacity, a glass rod. In addition, we need a weighing machine, preferably an electronic balance of about 200 gram capacity and accuracy 0.001 gram. The reagents that we need are acetic acid glacial, sodium thiosulfate of LR grade, potassium iodide and starch powder. First, we prepare the reagent solutions. Sodium thiosulfate solution of concentration 0.01 N is prepared by dissolving 2.482 gram of the material in 1 liter of deionized or double distilled water. Starch indicator is prepared by dissolving the starch powder in water and we use only the supernatant in the testing. Alternatively, we can prepare the indicator using a mashed potato and allowing it to stand along with water for 24 hours. Again, we use the supernatant material in the testing. First, fill the burette with the titrant. Now, we will take some suitable volume of sample. The volume should be taken such that the amount of titrant consumed should not exceed 20 ml. In this case, let us take a volumes of 200 ml. Alternatively, we can also use a measuring cylinder. Now, in this sample add 10 ml of glacial acetic acid. Now, add 1 gram of potassium iodide crystals and stir the sample . Allow it to stand for some time for color development, and meanwhile we can note down the initial reading. The color should always be viewed against a white background. Now, titrate the sample till the yellow color disappears. Now, we will add starch solution . Dispense 1 ml of the supernatant . Now, retitrate till the blue color disappears. Note down the final reading. Repeat the test till you get concordant value. The concordant reading is 0.15 ml. The residual chlorine is determined by using the formula V1 into N into 35450 divided by V2, where V1 is volume of sodium sulphite used, V2 is sample volume, that is 200 ml for this case, and N being normality of sodium sulphite, which is 1 by 100. The residual chlorine value for this case is determined as equal to 0.27 mg per liter. Another method of measurement is using a chlorine kit. The residual chlorine kit is an assemblage of glasswares and simple chemicals. We have two cylinders having graduated mark for 50 ml, a pipette of 5 ml capacity, or we can use a cylinder also of 5 ml capacity, a glass rod and Chlorotex reagent. The process is quite simple. In one cylinder we take 50 ml sample and in the other cylinder we will pour 5 ml of the reagent. Now transfer this sample into the cylinder containing reagent. Stir it for a while and leave for a period of 1 minute. Now this reagent bottle has a color chart on it. Sometimes the color chart may be separately available. There are various colors embossed against which the residual chlorine value is mentioned. Compare the color developed in the cylinder with the color comparison chart and find the matching tint. Now here we can see that the color matches with this tint, corresponding to which the residual chlorine is 0.5 ppm. Correspondingly, we can see that the water is suitable for use, that is, the chlorine is adequately available in the sample. Now, this method gives you very quick results, but simultaneously they give quite approximate values. However, for routine analysis they provide a good guideline. In order to make precise measurements, we must adopt to the iodinometric or spectrophotometric method. Thank you and goodbye.